Okay, before answering this exam question, I'm just going to go through this example here. So you have sine 30 equals 0.5. They've given you the answer. But they could just say sine x equals 0.5. And this is a calculator question. But if you inverse sine this to get x, that would actually equal 30. So x equals 30. Now, so what they're saying here is, look at the symmetry of this graph. It repeats every 360 itself. So it's called its period. Now, imagine where 0.5 is here. So what they're saying is, if you draw a dotted line here, that would be 30 degrees. Now, can you see this point here, where this hill shape is perfectly symmetrical. So if it's 30 from 0, you can see from 180, from here to here, it is minus 30. So this answer must be 0.5, and if I reveal the square, that would be correct. Now what about sine minus 30? Well, this is minus 90 and it's minus 30. Now this is an important point. So from here to here, this U shape is symmetrical, but a reflection of this one. So minus 30 is just going to go exactly down here, and if it's a symmetrical reflection or a reflection, that must be minus 0.5. So this is minus 0.5, and if you check that on the calculator, that's the answer you get. Now let's look at sine 210. Can you see sine 210 will be 30 on here? So that'd be plus 30 this way. And you can see the symmetry, it will be also be minus 0.5. And you can check on the calculator, and that would be correct, and that should make sense. So for this question, it is a calculator question, so you just inverse sine this number 0.6691, and then you would get x equal 42 degrees to the nearest degree. Now, I'm just going to say 42 degrees is approximately here. That's 42. So this point is the 0.6691. I'm just going to call that 0.67 for now, just to round it up. So if you look at the symmetry here, you've gone essentially plus 42 this way. So from 180, if I draw a line up, so you can see that must be minus 42 from 180. So 180 minus 42 equals 138. So that answer is 138. Now if we carry on from 0 to 360, you can see it doesn't match again, so that's the only answer. And you check on your calculator, that would be correct. But if they extended that range to minus 360, which could happen, that's why it's important to learn the graph. Can you see it matches here? And we'll go down here. Now, can you see it's plus 42 from here to here? And look what way it's moving up or down here, or the symmetry of the graph. Can you see that is minus 42 this way from minus 180? So minus 180 minus 42 would equal minus 222, and that would work. And you can try it on your calculator if the range was from minus 360 to 360. And I hope you can see that. If I shade that in, that might help. So let's explain this question. Cos 60, they've given us it here, but they could just say cos x equals 0.5, and you'll just inverse cos 0.5 to find that it would equal 60, so x equals 60, if they don't give you the value. So let's look at 0.5 here. And it doesn't need to be accurate, you just need to know that's 60. And the range is between 0 and 360. So you can see that that point is exactly here if we go along. And if you know to sketch how to sketch your cos graphs really well, you can see between 90 and 60, that is a distance of minus 30 degrees. And look at the way it's going. So from 270, the graph is symmetrical, so this way must be plus 30. So this answer here must be 300. So cos 300 also equals 0.5, and you can double check on your calculator. But look at this question here, they're asking for what is cos 120? Well, you can see cos 120 is here, and so it's plus 30 this way. So this point is 120 degrees. Now, if you think about the symmetry of the graph, it's a reflection from the hill to the U, let's say. So that must be 9 minus 0.5. That is 0.5. And if it asks for cos minus 60, well, cos minus 60 is here. Well, between here to here is 30, correct? 60 and 90. And between here to here is 30. So using the symmetry of the graph, where it's symmetrical right here, you can see that that is 0.5. That is minus 0.5. And let's look at cos 240. That's minus 30 this way. And you can see the symmetry from 180. So that must also equal minus 0.5 if you continue the line here. And this example I did at the start, this is where you get the formula cos x equals cos 360 minus x and you can see that from this example I did here. If we did more examples we could prove this, but essentially I don't think you need to remember the formulas as long as you can remember the graph and you can see it and use it yourself, and that should really help. Now let's look at this question here. You can use a calculator. So step 1, cos minus 1 minus 0.4226. It says it's the nearest degree. Use your calculator. Now let's look at this question here. But now it just says cos x equals minus 0.4226. So you'll just input that into the calculator, and to the nearest degree x will equal 115. Now 115 will just be 25 degrees in. So that's, I'm going to write that up here, plus 25 from that bit, 90. And it says only from 0 to 360, and just going to write that's 125 right here. So you have to look at the symmetry. So like the other example I did, from 270, that must be minus 25. And again you can see that cos 115 will equal cos 360 minus 115, which equals cos 245, and 270 minus 25 equals cos 245. So that answer is 245 to the nearest degree. And you can see this formula that they give you for cos, but you don't need to remember it as long as you remember the graph, and you need to remember the graph anyway. So to reduce your cognitive load, just remember the graph and that is enough. And I want to just flick back to the sine slide, and that's why you get this formula, sine x equals sine 180 minus x. And you can see why sine 30 equals sine 150, because that exactly fits that. So when x is 30 here, 180 minus 30 equals 150, and this all works because of the symmetry and the shapes of the respective graphs. And I hope that really makes sense, and that will help you a lot